All right, so greetings. Welcome to Eureka Math Squared, grade 6. This is module 2, lesson 21. We're going to hang out on page 263 today, dividing a decimal by a whole number. And before we actually just start dividing, we're going to, I guess, deal with a couple of fun little things that happen here when you are dividing that make your life a little bit easier, like some reasoning. So using some, I suppose, math common sense here. So what they're saying is, hey, here's a problem. So here are the digits in the quotient. Which quotient is actually correct? Well, one of the rules I love to stress in the class is, hey, listen, if you have a division problem, right, let's take this guy right here, right? And one of the rules is, of course, get that decimal right up there, put that little arrow if you want to do that. We always, here comes the quote, right? So the, let's see, the quotient value, I don't know if I should write this. It's going to take a long time. The quotient value goes above the last digit that you are dividing into. Da-da-da. Okay, words of wisdom for today. So here's what I mean by that. See that 3? All right, does it go into the 1? No. Does it go into the 16? Yes. Now, what is the last digit in the 16, right? We're dividing into the 16. It is the 6. So my quotient value, which happens to be 5 in this case, right, goes right above the last digit of the number we're dividing into. So it doesn't go above the 1. It doesn't go above the 8. It goes right above that 6, right? So we're dividing into 16. The last digit is the 6. The 5 goes above the 6. It's the last digit of the number that we are dividing into. And there it is. It happens to be in the tens place, right? So tens place, ones place, decimal. So the logical answer is this guy right here. There you go, right? Because the 5 is in the tens place. And over here, it's in the hundreds place, right? Here, the 5 is in the ones place. And over here, the 5 is in the tenths place. So there's a little bit of reasoning for you without actually having to divide. Okay, so we're off to a good start. Next. Along those lines here, if you know your little multiplication times table facts for 12, you'll know that 12 times 12 gives you a 144. Now watch what happens here, right? So if, right, I move that decimal, right? So if that decimal hangs out over here, it's logical to assume then, right? So we're not going to have 12 anymore. So the decimal moves in, I suppose, in my quotient, and I get a 1.2. So the decimal was here, now the decimal is here, and now the decimal is here. Since we're dividing by the same value, it's now logical to assume, we can reason that now we have an answer of 0.12. Okay, now cruising along to the next one, well, look what happens to my 120 here. Now, here's how I run this deal. You see how much fun I'm having dividing by 12? I just want to continue to divide by 12. So 120, if I am going to turn that into 12, simply means I'm going to divide that value by 10, right? So if you take a 120 and divide by 10, right, you get 12, right? Everything loses a place value, right? The decimal was here, and now it's hanging out over here. We're dividing by 10, everything loses a place value. However, things need to match, right? So if I lose a place value here, I'm going to lose a place value here. So my decimal winds up over there. Aha, so look at the pattern. Da-da, da-da, da-da. Since I'm dividing by 12 again, now that 12 loses yet another place value. See? Now I'm going to do something similar over here, but instead of dividing by 10, I'm going to divide by 100, which means 2 place values get lost. And if that's the case, 2 place values get lost over here as well. And I wind up with an identical expression, right? So if that's true, then my answer has to be the same thing. There you are. All right, so that's that deal. And we're really not even dividing yet, even though the whole lesson is supposed to be about dividing, right? Speaking of expressions that are equivalent, this guy here, okay? So we're going to use that same strategy of multiply by 10, divide by 10, whatever you want to do here, to both values to get equivalent values, right? So if I multiply this guy by 10, I get a 90, right? And if I do the same thing to this guy, right, everything gains a place value, right? 426.8, there you are. So these guys are now equivalent to one another because I perform the same operation to both sides of the problem. Okay, another way to look at this is to turn into a fraction. right? Since fractions are division problems, right? We can do the same thing. How about I multiply by 10 for each of these, right? Multiply by 10. So now I have a 426.8 over 90, right? And I get the same quotient either way. Now, if I want to rewrite that as a division problem, that's fine too. Here it is, 0.8 divided by 90. There you go. Okay, so I can keep on going. Maybe I can just multiply these by 10 each, and I'll come up with something else, right? Everything gains a place value again. How about a 4268, right, over 900, like that. So I can keep going with equivalency and having a lot of fun, okay? So let's start dividing, finally, right? Okay, well, first they want us to estimate. And if I have a single digit, I leave it alone. So I'm going to put that 5 right there. Divide by 5. And it's just a matter of this guy. I need a compatible number. I don't necessarily rhyme this value, but in this case, round this value. But in this case, knowing my 12 times tables, right, I'm going to turn that into a 60 because that goes 12 times, right? I'm going to put my little about squiddly, right, because this guy, they're not directly related, right? They don't have the same answer. It's an about, it's an estimate, okay? So one thing's about the other. So my quotient, by the time I'm done with the exact answer, should be about 12. So let's see. Right, first number goes in the house, so here comes the house, right? First number goes into house. Second rule, get that decimal up there. And now we're ready to go. So 5 into the 6 goes once for 5. Take your time with this, don't rush. There's a 1, bring down the next bugaboo. Now remember, if I'm dividing into 11, the last digit is this 1. So my quotient value goes above that value. There it is, right above it, right? So 5 goes into 11 twice. There he is, for 10. Subtract to get 1, bring down the next guy, right? There's a 6. Now there's my 16, right? The last digit is a 6, so it goes above that 6. So my next quotient value, which is a 3, right, goes above that 6, right? So there's a 15, subtract to get 1, bring down this guy, and there's that 3 times. There we go. For 15 with nothing left. And there you have it, folks. Keeping things nice and neat. If you bring it down, you must divide. All kinds of fun little rules, right? Since I brought down that 5, I had to divide into it. Yada yada. So that's the deal with division, and hopefully you enjoyed that. All right. Thanks so much, gang. Take care. Bye bye.